Welcome to the simulation of a current Thread-Widening process for hexagonal nuts. The system uses a 5-spindle drilling machine operated by one operator as we see here. The company's daily production requirement is 10,000 nuts during an 8-hour shift. In this video, we evaluate the baseline performance of the plant, visualize the workflow, and identify the operational inefficiencies preventing us from reaching our goal. Let's review the technical configuration of the plant. The arrival in the source, we have the arrival time of 14.40 seconds, and it is important to know that one flow item that this source block gives represent and 5 batch of 5 nuts. The pre-machine storage is modeled as a queue, with a capacity with 2000 batches. The core of the system is the drilling workstation that we simulate as a process block and with a process time of 30 seconds per batch. This process requires an operator that gives an 18 seconds for manual loading and 9 seconds for drilling operation and a 3 seconds of material removal. Well, in this we can see the operation processing that we have for the process. And as the simulation runs, we can observe a great bottleneck at the drilling workstation. Because dispatches arrives every 14.4 seconds, but the machine takes 30 seconds to process each batch. The material accumulates in the pre-machine queue. The root causes of the limitation is the manual handling of the material. Out of the 30-second cycle, 21 seconds are dedicated strictly to the manual loading and unloading of the nuts. This heavy reliance on manual labor severely restricts the actual production capacity of the drilling station, generating a continuous workload on the operator and a growing backlog. Well, for the performance indicators, we have that at the end of the 8-hour shift, we can confirm as our visual diagnosis that the system only completed 959 batches, which equals around of 4,795 nuts. This means we fulfilled just 48% of the daily production target as shown in here. The batches are left in the queue previously to the machining process, representing a massive work in process. The drilling machine and the operating shown are resource utilization of 99.9%, proving that the workstation is operating under absolute saturation. Demonstrating that this current manual process is unsustainable, setting the stage for automated improvements that we will make later on the second video. Thanks.